Good morning, everyone. It's 1 past 10. I think it's time to start this meeting and welcome on behalf of all the members of WatEnerWine Project Consortium. It's a pleasure to join more than 100 wine industry stakeholders, and not only regarding the quantity, but the quality of these stakeholders. We're going to we're going to invest 3 hours learning about how to be more efficient and effective in energy and water management. As you will see, the event have two main parts. Main parts. In the first one, we're going to tackle energy and water with inputs from experts and technological centers and clusters. And in the second part, we are going to listen good practices, methodologies, and technologies from wineries. It means from real end users. And I think it's a very interesting experience to learn about them. So let's start with the detailed agenda of the meeting by Gracie Boland from Innovan, and who will be also the moderator of the event. So Gracie, the floor is yours.
Thank you, Eloy, and thank you to all of our panelists and, of course, to all of our guests and visitors for connecting today to hear about these interesting topics and very important topics of energy and water savings in the wine industry. I think in the 3 countries which are represented by the WatEnerWine project, and of course on a European and international level, these topics are indeed really at the heart of the trends and knowledge right now. And we're happy to be able to share this information, as Eloy said, through experts and also through wineries. So a quick look at the detailed agenda. So we will have an introduction of the European project, WatEnerWine, to tell you a little bit about what we're doing and the context of the webinar today, followed by a few words from the European Commission. So the authors of this call, who can talk on a general knowledge level on the importance of these topics on a European level, followed by cross-sectoral learnings from 2 technical centers in Catalonia, Eurocat and the Catalan Water Partnership. A look into the current needs of the wine industry, also thanks to you who might have participated in our survey. Chiara Pezzi, the project manager of Cluster Agri-Food in Emilia-Romagna, will share knowledge and survey results from the project. We will continue getting more specific into the wine industry with best practices presentation in water management from Jean-Michel Dessaigne from the IFV in France. And then thank you so much for registering for a 3-hour webinar. So we will give a 10-minute coffee break, email break, to disconnect for a second, and then to rejoin us at 11:30 for 4 panelists who will share best practices in the wineries, from producers themselves to researchers and to engineers. We will have an overview of some specific practices that have been put into place in different wineries. And then to conclude, we will share opportunities and going forward, whether it be through the project WatEnerWine or through other cross-sectoral and wine industry projects. So thank you very much for connecting. Just a few housekeeping details before I let the experts speak. So on the bottom of your screen, you should see a Q&R section. So if you do have questions, please write them in the chat and we will be able to either answer them directly through the chat, through the Q&R forum, or answer them out loud at the end of the webinar. And also the WatEnerWine team speaks English, Spanish, French, and Italian. So please feel free to write your question in one of these languages if you feel more comfortable. Also, all of the presentations will be made available after the webinar, in addition to other information to go further, such as articles, resumes, and other survey results. And the webinar is also recorded and will be made available. So thank you very much for connecting. And now I will give the floor to Alba Valles, WatEnerWine project manager, to give a brief introduction. Thank you.
Thank you, Gracie, and hello, everyone. Good morning. Very quickly, I wanted to highlight the consortium of the project. who promoted this initiative. So first and foremost, the project participants wanted to reflect different actors that should be represented in the Agri-Food Sustainability Cluster Partnership, which is a goal and main focus of the call, and the wine industry. Therefore, the partnership includes 3 agri-food wine clusters, Innovi, Innovan, and Cluster Emilia-Romagna Agri-Food, 1 industry support organization, the Catalan Water Partnership, and 2 agri-food technology centers, Eurecat and the French Wine and Wine Institute, the IFP. A little bit of introduction and context on the project. So the European wine industry has a long history dating back thousands of years and has been facing several challenges such as climate change, declining wine consumption, and increased competition from other wine producing regions. Despite these challenges, the European wine industry continues to be a significant contributor to the European economy, as it covers 1.8% of agricultural land, but generates 16% of agricultural turnover after processing. It should also be highlighted that wine production is vital for rural areas, as it contributes to landscape preservation, quality tourism, and keeps a permanent population. Wine growing is even also important in terms of employment, and it is one of the most important socio-economic activities in the world, particularly in Europe, and is cultivated in almost every region in Southern Europe and plays a substantial role in that economy, highlighting France, Italy, Spain, and Portugal, which also relates to the big picture of the consortium that I explained earlier. Wine production offers an example of an activity where processing takes place on the spot, so the added value remains in the production region. That value can also be increased to the benefit of the producers if they sell directly from the holding. The project wanted to continue with the work done by another previous European project called EPAWI and the WICA, the Wine Innovation Collaboration Alliance. So the WatEnerWine project builds on a needs analysis produced during that project, in which more than 600 wine grape growers and wine producers all over the world expressed their needs and priorities and their main challenges. So through that project, the top 3 challenges, which also relate to sustainability priorities focused on the call, are to reduce energy use and improve energy efficiency for production through the use of less energy-intensive and low-carbon technologies, first. Second, to increase the use of renewable energy sources. And third, to improve water efficiency. This is a little bit of context. And then the focus of the project. So the main objective of our project is to support actions for the establishment of new European agri-food sustainability cluster partnerships, focus on boosting, promoting, and implementing the uptake by SMEs of resource efficiency technologies in the field of energy and water, particularly energy efficiency, renewable energy, and water management and efficiency. So this big goal is vertebrated in 6 specific goals, which are to create a network of clusters, organizations, BSOs, to promote the main objective of the project, to improve structures and capabilities of these organizations to support then SMEs in this sustainability transition, to improve wineries' energy and water efficiency and management, to reduce GHG emissions and use of resources, and also reduce operation costs, and overall involve organizations into the EU sustainability initiatives and the ecosystem. And with this, how do we do it? So the objectives of the project are pursued through different activities divided in 5 work packages. We have the coordination and management work package, and then in more focus, we have what is happening. So in the second work package, we want to have a bigger picture on the SMEs, the needs, the challenges, what is going on in the wine ecosystem, but also in other agri-food sectors. Then we work for the strategic cooperation and the establishment of partnerships for sustainability. And finally, we directly and more focused work with SMEs to support SMEs to uptake resource efficiency technologies in the field of energy and water. And overall, we also have a work package for dissemination and activities to multiply the results and outcomes of the project. And this is all for my part on the context of the project WatEnerWine. Thank you very much.
Thank you very much, Alba. And to go a bit further into the context and this call from the European Commission, we are happy to have Mr. Jonas Lazaro Mojica, Policy Officer from the European Commission, the DG Grow Unit F3 Food Ecosystem. And so thank you, Jonas, for being here. We're looking forward to hearing what you have to say.
Thank you and good morning to all. I hope you can hear me properly. Yeah,
yes,
perfect.
Yes.
Well, first, thank you for inviting me today to this webinar, which I see is having a lot of success, and I'm really looking forward to see the contents of this project. Perhaps I'm here just to tell you a little bit on why we thought of this call, because in our unit we're the developers of this single market project called through Cosme, and what were our intentions and expectations. So it's just to kind of set the scene, although I know that you want to hear about wine, so I will be very short because this is more overarching. But back in 2023, when we had major issues coming, obviously we were working on the green transition, so obviously on issues related to the environmental sustainability then, but also we were very concerned about the energy prices, also the inflation in products, which still continues, I have to say, and also the difficulties for stakeholders, for processors to actually produce and find the right solutions to it. Now, I have to say that we were also concerned about small and medium enterprises and mid caps. So really our question here when we propose this project is first, how can set up a project where we have an ecosystem where small and medium enterprises can collaborate, clusters, and anyone that is working more at a granular level. Also, we wanted to include food industry because very often projects goes either to primary producers or consumers, but there's not so much on the processing itself. I want to have more on that and more into the implementation. For the implementation and the impact, we thought that we needed really the actors really to be part of. So having these elements into consideration, the project, we call it as partnerships. We wanted to include really those that are working more at local level or at a national level, really working in the field to actually have more results and projects. So we wanted to go from something less theoretical and more implementation by just giving capacity building and giving some money. I know it could be bigger, but this is the money that we had for the call, which were 3 million for about 3 projects to help some sectors to actually collaborate and do a little bit more with some public funds. So that was really our intention. In terms of expectations, we want to see this on the making. So we see that that collaboration takes place, that you that are the stakeholders actually are able to come up with best practices from your exercises and to come up with solutions which are useful for stakeholders, and that we can use this kind of projects as a pilot to have more, because really from our perspective, really it is very good to have projects at the inside of things at the cluster level where you really have the actors playing at that level. I will leave it there because I'm not speaking about wine, and I think this is all about wine and very interesting things. I just wanted to set up the scene and tell you that I'm very grateful for this project, and thank you for inviting me today. I'm really looking forward for today's outcome.
Thank you very much, Jonas. And it is reassuring to have this call and these European funds dedicated to good practices and to capacity building on a multi-actor level. So through technical centers, clusters, and producers themselves to really be able to do practical actions for the well-being of industries. And in our case, like you said, specifically the wine industry. So thank you very much. So later in the project, later in the presentation, the producers that are connected and also the suppliers, you will see how to be directly involved in project activities. But before going directly to wine, our next presentation will be from two technical centers, Eurocat and Catalan Water Partnership, who will share with us some best practices from agri-food sector in general, because I think also in today's context, the wine industry, we see that we are in some challenging times, and to learn from other industries, to diversify your activity can also be ways to overcome a challenging period. So please welcome our next speakers, Andrea Navis, Victor Fuzes from Eurocat Technical Center, and Aina Eminegul from the Catalan Water Partnership. The floor is yours.
Thank you very much, Gracie, for the presentation. I hope you can see it well, the slides, right?
Yes, Aina, maybe put it in presenter mode if possible.
Okay. I have to check it again, so I will share again my screen. Can you see it now in presentation mode?
We still see the slides. Try clicking the...
I will try to maybe share my PDF mode presentation.
Now, I know.
Can you see now?
Perfect.
Yes.
Well, fantastic. So thank you very much, Gracie, for the presentation, and good morning, everybody, as well. As Gracie said, and she mentioned, I'm Aina Mengual, project manager at the Catalan Water Partnership, and following the Water and Wine project introduction and the Mr. Jonas Lazaro's overview of the call and the importance of saving waters and energy at the European level, we would like to share together with Eurocat some of the cross-cutting lessons we have explored during the initial phase of the project. So we will present the main challenges, good practices, and success stories from other agri-food sectors, aiming to bring this learning closer to the wine sector. So first, a quick words about who we are. So the Catalan Water Partnership is the Water Sustainable Cluster of Catalonia, non-profit strategic association that currently brings together 168 public and private companies, research centers, and universities. And our main mission is to boost the global competitiveness of our members. And now we are the second largest water association in Spain. And over the last 15 years, the cluster have led over 120 projects with strong members' engagement. Also, it's good to say that one of core pillars is the cross-sectoral cooperation. And in the case of the Catalan wine sector, we have been working together with Innovi cluster for more than 8 years through joint projects, studies, workshops, and other events. And thanks to this experience and also the know-how of our members, our goal is to support a fair and effective water transition across sectors. And today we are putting the spotlight on the wine industry across Europe. So now a brief introduction of Eurocat. I give the floor to Andrea.
Good morning, everyone. My name is Andrea Naves. I am a researcher in Eurocat. We are a technological center located in Catalonia, in Spain, and our activity is mainly focused on applied research and
Andrea?
normally our projects normally start with applied research, and we achieve normally product development. And here in this slide, you can see our 4 main knowledge areas with the different topics that we work with. My colleague Victor and me, we work in the last one in sustainability area in energy and water departments. Okay, so thank you.
Thank you, Andrea. So now we will go into details more in what are the main water-related challenges the agri-food sector is currently facing, and the answer lies in new challenging priorities and growing pressure on demand, of course. So really, we are all aware of the increasing impact of the climate change and drought. Studies also estimate that by 2050, over 1 million people will be living under extreme water stress, and worryingly, the darkest red zones on the map, meaning the most vulnerable, include Europe's top wine producing areas, France, Italy, and the Iberian Peninsula, Spain, and Portugal. Another major change for the agri-food industry is the need to improve the optimization, water efficiency, and to adopt circular economy strategies, all while complying with increasing new regulation requirements, of course. And this means taking action on multiple fronts, like you can see in this slide, exploring, for example, alternatives inlet water sources, like, for example, rainwater harvesting, also optimizing production processes, especially cleaning processes, for example, by introducing internal recirculation systems and digital and innovative technologies, also improving wastewater management through advanced treatment and safe reuse in irrigation, for example, or even industrial processes, always in compliance with legal parameters. But before any of that, companies must first understand their own water cycle by conducting, for example, spare water audits and developing both short and long-term strategic plans. Of course, knowing your water footprint and benchmarking it against industry standards can be a powerful tool. Sorry, both for positioning your company and for considering innovative practices such as water offsettings. That is compensation, for example, and improvement in the environment. In fact, just last year, the European Commission and Social Committee published an opinion highlighting the needs to fully integrate water into the European industry strategy, putting water resilience on the same level as decarbonization, for example. This means moving towards a more water efficiency industry through advanced water treatment technology, water reuse and reduce consumption, as I mentioned. And according to the last year Water Europe report, 4 sectors are identified as both strategic and highly water intensive. That is the semiconductor sector, batteries, data centers, and of course the agri-food industry. And finally, we cannot ignore that the consumers are demanding more sustainable products. For example, we can show you a global study from 2022 with over 19,000 respondents found that found that 62% of consumers are willing to change their purchasing habits to reduce the environmental impacts. So that's the main challenges that we have faced, that we have recuperating the water sector. And I now give the floor to my colleague Victor, that he can explain a little bit about the energy.
Thank you, Aina. Well, in the energy field, the most success stories cases follow a similar pattern in this and in the same order. The challenges are saving energy is the first one, reducing consumption, using better that energy through increase of efficiency, and the last one should be replacement of fossil energy sources with renewable and the fossilized ones. This leads to greater instability of supply because the renewable sources are more irregular, but a greater security, bringing the sources closer to the point of consumption. The way to achieve this challenge also follows a similar scheme. The first step is study the starting situation to identify quantities, flows, needs, losses, opportunities. This is achieved with energy audits and through digitalization and data analysis. It's needed to do relevant measures to monitor consumptions all over the processes and having some kind of management capacity of these processes. And also it's interesting to study the relationship between water and energy consumption that it's often interesting to explore. The second step is usually to improve the energy using heat recovery systems, better insulations of pipe, furnaces, boilers, also motor and fan speed regulators, or introducing innovative processes. The last step should be the substitution of fossil fuels for other renewable energies, which allows to be the owner of the energy sources to achieve greater energy security, despite of the requirements of a high initial investment in exchange for almost zero marginal cost of energy, and having to deal with this fluctuating nature of energy sources. Please, next slide. The classic approach of all the cases, it's usually an approach that tends to be not touch anything of the process and try to replace grid consumption by photovoltaic panels, and it's the classic approach of panels on the roof. That is the first image. Then in this case, it's a summary of several cases that I've seen in several years. In this case, the following paradox appeared: despite producing the same amount of annual energy that it's needed, only a small percentage of this energy can be self-consumed. In this example, was only 43% in the first year. The rest is exported to the grid. The advantage of recording production and consumption is that it's easier to analyze. The reasons appears easily. Without storage, when there is an excess of electricity, it's immediately exported to the grid, and this can happen minute by minute throughout the day due to the lag between production and consumption, throughout the week due to effect of weekends and holidays, and throughout the year due to differences in summer and winter insulation. Then smarter strategies need to be established. Please, next slide. Then the last one for this introduction is the key to evaluate both the key is to evaluate both the electrical energy and other needs. The heat needs differentiate by temperature levels. Optimization strategies mainly involve improvements in insulation and the use of heat flows from high temperature processes to low temperature processes with the help of heat pumps or absorption machines. Then on the other side, the fossilization have many options. The fossilization have there is no clearly a better option, but rather a wise choice of needed. A wise choice is needed. The options are many. They go through geothermal, aerothermal, solar thermal, photovoltaics as energy sources. There are different ways to consume, like electric vehicles, or ways to stretch this energy, like in electric batteries or thermal batteries, or even for long-term storage using biogas in digesters provided by organic waste. And that's all for the introduction. Thanks, Aina.
Thank you, Victor. So after this brief overview of challenges and good practices and that introduction that me and Victor made, we will now show some real life success stories from the agri-food companies that have already implemented water and energy saving solutions, different from the winery sector, because afterwards we will have the opportunity to listen to some success cases in the winery sector. So regarding water, let's start with DAM, a major brewery located near Barcelona. Despite increasing its production by 60% over the last decade, the company has kept its annual water extraction at the same level. They, for example, implement different solutions, implement water use closely using flow methods, and have calculated their water footprint with a strong focus on reducing it across the entire value chain, especially in agriculture, where barely represents 95% of their water footprint. And within the production plant, they have achieved 34% water savings through measures like recovery of hot water from waste production for cleaning, optimizates reverse osmosis treatment, and investment in high-tech, for example, pressure to reduce water use. Additionally, DAM has improved its groundwater management by returning 25% of its annual water consumption to a nearly aquifer, the same source from which the company extracts its water. Next, we have the Liquats Vegetals, a company dedicated to the production and marketing of plant-based beverage located in a natural park in Catalonia. By installing flow methods and adjusting cooling flows, they have already reduced water consumption by 11%. They also applied internal recirculation systems using ultrafiltration, reverse osmosis, and clarifications, disinfection, saving another 8%. And at the end of the last year, they have implemented a new system to regenerate water from their own wastewater treatment plant, covering 100% of their cooling needs without using drinking water. They also install a high efficiency reverse osmosis system to supply water for boilers, which is expected to reduce water use by an additional 10%. And a different case came from Costa Brava Mediterranean Foods, a meat processing company with 17 plants worldwide. At the Catalan production facility, they implemented an advanced treatment system for their own site wastewater treatment plant. Following a pilot phase and close monitoring, the treatment water meet the regulatory standards for reuse in cooling system, stream circuits, and for cleaning trucks and livestock areas. And this results in an 18% reduction in water consumption, along with significant, as Victor said before, significant energy and carbon dioxide savings. That's also one example of both together good practice. They also monitor the sterilization process to cut water use and reduce operation costs, saving another 5 to 10% in water and achieving further energy savings. And finally, I want to also present the Coca-Cola's plant in Catalonia that runs environmental offsettings and local ecosystems restoration projects. They return over 9,000 cubic meters of water per year to the environment, helping also, they have a project for helping to restore river connectivity between the coastal mountain range and the Besòs River. It's a river near also Barcelona. And they are also supported water sustainability project nearly Valencia, introducing efficiency irrigation and fertilization in 12 circus farms, which lead to a 12% reduction in water and energy use. Also, it's good to say that within their own factory, they implemented a reverse flow osmosis system, boosting systems efficiency to 96% and reducing both water discharge and energy consumption. There are just a few examples on how agri-food companies are improving their water management. And now I will take the floor to my colleague, Victor, so he will present concrete examples and success cases reducing energy use.
Thank you. this is the first example that I have chosen. It's an example of integration, a vertical integration of the processes, because they include also agriculture. They are a cooperative that is producing fruits in Lleida, in Catalonia. And then this study was the point, the departure point. It was that they have a great availability of land and photovoltaic surface, because they have a lot of lands, but the starting point was without digitalization. They didn't know the energy consumption of their plants, of their fruit processing plants. Then the project was initiate the digitalization, measuring everything in the processes, and also to develop some of the optimization tools to begin the management of the processes to regulate all the consumption. The second one was to introduce or to measure the photovoltaic production of the roof. They put a lot of photovoltaic panels on the roof of the plants. But on the other side, it was the classical example of distortion between the production and consumption, because the conclusion was that they need some batteries storage systems for the electric storage in a day or in a week. But the problem was between seasons. Then a first proposal of studying some hydrogen process, some hydrogen machines to storage energy between seasons was proposed. And the last idea was to introduce the thing that in France it's more developed than in Spain, that it's all the agrivoltaic systems, in order to achieve saving in water in the fields, because with the photovoltaic on the trees we can achieve. In the first study, in the preliminary study, showed water saving in the fields of 10-15%, and also a great production of electricity. That in this moment the problem was to put this energy to the grid, because of the connection points and difficulties of the grid in the land. Please, next slide. There are 4 cases in this slide. The second one, it's a summary of different cases. It's all these cases are on the same project, that is element 21. The conclusion of this project was the main electrical consume of the plants were normally in refrigeration systems. That it says that 70% of electricity consumption is attributed to compressors and used in refrigeration systems. This is for the meat sector. The process was the same, was introducing sensors and digitalization for measuring almost everything, temperatures and electrical consumption. Then the second step was to put some data analysis and development of some algorithms to identify patterns, to identify ways of optimization of the consumption, and introducing some artificial intelligence to identify automatically these patterns, and to identify not only the things that we could think that is important, but the things that is derived from the data analysis. In this case, the reduction, without touching anything, without changing any machine or any fridge or any device, was between 10 and 20% of the energy consumption. Then please, next slide. Previous, please. This is the last one. The third cases were for the milk sector, and this was a bit more difficult, because we needed to change to propose some changing in lighting, because it's the first in this sector, was the first that was important to change classical lighting for LED lamps, and put some energy management systems to close and light the light a bit along the day. It was not so important like the previous case, because the reduction was only 5 or 6% with these decisions. Wait, something has changed. Sorry. And the way of working was the same. Was digitalization, was measuring everything and put some energy management systems. And in this case, it was not so spectacular, but because the result was only 10%. But the options can be achieved. Some studies can be done. Then the last one is because agri-food sector uses lots of suppliers or lots of secondary industries, and in this case, the study was interesting also because this supplier, it was working with the cork taps, no, the taps. It was I don't know the name. Sorry.
Corks is correct, Victor. Perfect.
Cork.
Yeah.
Then the classical approach was the same. This industry was worried about the carbon footprint of his activity, and the conclusion was, the first step was introducing photovoltaic roof, but the conclusion was the needed of energy in this process was not only for electrical processes, was even for uses of fuel, uses of vapor temperature processes, and the conclusion was to change the point of view of changing fuels for electric vapor furnaces or boilers, and sobre todo, no, and overall. For changing the use of fuel in logistics systems, in the use of lorries and cars. Then this enterprise had a lot of excedent of electricity, but he could not change for electricity consumed to fuel consumed, and the storage between the year all over the year was the great deal for this process. We could change some fuel consumption to electricity consumption to produce steam, sorry, but we could not change the logistics chain because the fuel was all over the processes, was very difficult to substitute for other sources, and the real challenge in this case was this option. With the changing of the steam furnaces, we achieve a 20% of self-consumption ratio increase. We could increase the self-consumption ratio from 46% to 70%. But the last one, the proposal was only to offer to the workers of the factory the use of the excedent of electricity for their electric vehicles. Then the balance was changing very fast because the carbon footprint of diesel engine is very high, and then changing to the use of the excedent of photovoltaic of the panels on the roof could change the carbon footprint of all the process of all the factory, not only for the processes for producing the cork, but in a general point of view, in a greater value. Then the energy exported to the grid reduces, the self-consumption ratio increases until 80 or 90%, and this is the the important thing, to have a general point of view of the processes, not only for electrical systems, but also for steam, heat, and fuels and fuel consumption. Thank you.
So finally, we will only want to show that final slide, that all that good practices and case study that we have presented together with Victor, there are lessons that we want to transform to the, want to transfer to the wine industry through the Water and Wine project. And as Alba explained in the beginning of the session, we want to support that transition of good practices from other agri-food sectors with supporting SMEs, with working groups, with innovative catalog, individual support actions, and also creating a common strategic agenda, this European agri-food sustainability cluster partnership, as Alba mentioned before. So thank you very much for the attention. And here in this slide, you will have the contacts of Victor, Andrea, and me from Eurecat and the Catalan Water Partnership. And we will be glad to respond the question that you will have at the end of the session. Thank you very much.
Thank you very much, Aina, Victor, and Andrea as well for your very interesting presentation. And just a reminder to all of our visitors here, there is a lot of dense information. It's also available in articles, and the presentations will be available and will be sent to you. So if you want to dive a bit deeper into some of these expert case studies and discuss with either Eurecat or the Catalan Water Partnership, that's also, of course, very possible. So we are happy through the project WatEnerWine to have these experts from cross-sectoral industries to learn from other agri-food sectors, to adapt practices to the wine industry and vice versa, of course, in other cases. So I do see that there is a hand raised. Please, if you would write your question in the Q&R forum, it should be open to everyone, and we will be able to answer your question in the Q&R forum. Thank you. So after having an overview of the context and the importance of energy and water savings, to also have some case studies from agri-food, we will now dive a bit deeper into the wine industry. And to do that, we will listen to our Italian partners from AgriCluster Emilia-Romagna and also Venedea with Chiara Pezzi and Gianni Trioli to look into some survey results that you might have answered and to understand and to see where your European colleagues are also in their actions towards saving energy and water. Thank you.
Thank you, Gracie. Can you see properly the presentation?
Yes, it's perfect.
Okay, thank you. So good morning, everyone, and thank you for joining us today. My name is Chiara Pezzi. I'm a project manager at Cluster Agri-Food in Emilia-Romagna. Today, I'm going to present the results of the European-wide survey carried out as part of WatEnerWine project, focusing on water and energy use in EU wineries. Generally, this work gives us a clear picture of the current needs of the wine industry in terms of environmental sustainability. So let's start with the sample analyzed. The survey involved wineries across all EU countries with a focus on the three main wine-producing countries, so France, Italy, and Spain, that are also the countries directly involved in WatEnerWine project. Our goal was to collect comparable data at European level to better understand, first of all, how water and energy are used, secondly, what technology are in place, and then what management practices are applied. Generally, less than 50% of respondents have not yet adopted best practices. Specifically, Spanish wineries are the most virtuous, while the Italian wineries, the ones with the least sustainable approach. In addition, around half of European wineries have adopted sustainable techniques related to energy savings, while the other half have focused on water saving practices. However, clear differences emerge considering single countries. For instance, in Italy and Spain, there is a greater implementation of energy-saving practices, while in France, but also in other EU countries like Portugal, Greece, Croatia, Germany, water-saving practices are commonly applied. Looking more closely at specific energy-saving practices, the first choice for European wineries is solar energy, for about the 7% of total respondents. Followed by the consumption monitoring for about the 15%, and then LED lighting, geothermal energy, and wind energy are used just only marginally. About the water saving practices, nearly the 50% of European wineries have adopted practices for consumption control. Then the 20%, the washing with more efficient systems, the 13% rainwater collection and treatment, around the 10% wastewater management, and finally, just only the 7% consider staff awareness and training to be essential. So the overall trend in energy saving best practice is clear, but significant differencing emerge considering single regions. For example, only 38% of French wineries that have adopted good management practices have chosen solar energy, compared to nearly 80% of Italian or Spanish wineries. Similarly, the use of geothermal energy or of LED lighting reaches 25% in France, while it is nearly non-existent in other countries like Italy or Spain. Similar results can be observed also about the adoption of good water management practices. held out the differences between countries are less evident. So, in conclusion, it is clear that European wineries still have significant room for improvement in terms of application of sustainable practices. So with WatEnerWine project, our goal is to provide all the necessary knowledge and channels and tools to start, or better, to straighten this process. Thank you very much for your attention.
Thank you very much, Chiara. It's very interesting to see the different countries represented, and also to see the main topics that are of interest. As Aina explained before, and as Alba will explain later, the wineries that are connected today, you have the possibility to participate in more working groups based on this survey and the questions and on your main needs. So we can also dive a bit deeper into the questionnaire produced by Chiara and this presentation. So thanks to those of you who answered the surveys to be able to give us this content. And thank you very much, Chiara, for this very interesting presentation on comparing the different European countries.
Thank you.
And now we will continue looking into the wine industry with the IFV, who will focus on water management in wineries. So we will see some of the subjects that Chiara brought up as priority. And Mr. Jean-Michel Desaigne from the IFV will talk about some of these subjects and some good practices to manage this. So I will just share. Okay,
Yes.
it's okay, Jean-Michel?
Yes, thank you, Gracie. Good morning, everyone. My name is Jean-Michel Desaigne, and I work at IAV, the French Wine and Wine Institute in Nîmes. I will be introducing the best management practices in wineries. So next, please.
Sorry, Jean-Michel, I'm coming.
Okay. Yes, as an introduction, I would like to present some IAV recent project on water and winery wastewater, since some of the data that will be presented comes from this project. The first project, Minimo, is a project that aims to bring together different agri-food industries, like wine, dairy, fruit and vegetables, and fruit juice. This objective is to reduce water consumption through water recycling or reuse, including or not water treatment solution and environmental impact methods like water footprint. The second project is OptiFluo, which is led by my colleague Pascal Poupeau. The objective is the reuse of rinsing water after descaling. Finally, the third project is the VitiReuse project, whose objective is the reuse of wastewater for vineyards irrigation, whether for urban wastewater or for winery wastewater. Okay. Thank you. So how can we save water in a winery? Overall, it can be summarized in three aspects. The first point is to know the consumption. The second point is to control, and the third is to minimize the consumption. As far as the knowledge is concerned, we need to know annual consumption data. These are fairly well known in the wineries. But for practical water saving application, it is necessary to know water consumption per operation or per equipment. And there are fewer studies and data available. The second aspect is control. This involves training and awareness employees, setting up indicators, and so on. Finally, to minimize consumption, action can be classified into 3 points with increasing level of involvement, increasing level of investment. Implemented good practices, optimizing processes, and recycle and reuse. This will be my main topic of my intervention. Thank you. Now, global water consumption. For annual consumption, there are already several studies in France and Europe, and I mention an example in the graph. On the x-axis, the annual wine production in hectoliters. On the y-axis, the consumption ratio expressed in liters of water per liter of wine. On this data, the average value is close to 2 liters of water per liter of wine, but this value has a little practical signification. In fact, there is a high degree of variability depending on the volume of the wine produced. Winery producing large volumes of wine have a ratio of 0.5 to 2 liters per liter of wine, with an average of 1 per 1. Smaller wineries in production have higher ratio because of the scale factor. For example, it takes more water to wash 10 tanks of 50 hectoliters than a 500 hectoliters tank. Also, consumption can vary depending on the type of production, white wine, red wine, wine with thermovinification, and so on. Barrel aging or bottling can also increase consumption. Next. Yes. To implement water optimization strategy in a winery, it is necessary to know consumption in details, and in particular, consumption per operation or per equipment. This requires significant work, possibly carried out by a design office. Mechanical water meters, or better connected meters, need to be used. For more specific studies, non-intrusive ultrasonic sensor can be installed on existing pigs. Lastly, full study requires the measurement of pollution flow, like chemical oxygen demand, suspended solids, and so on. The final objective of the study is to establish what it is known a flow sheet, the flow of water in the winery. I mentioned an example on the slide for a bottling site from the reception of wine to the bottling tanks with a tartaric stabilization on the cross-filtration stage. Next, thank you. The advantage of this type of study is to establish precise and global information of water use in a winery. For example, in the table in the slide, the consumption data are classified according to annual water consumption. They could also be expressed in terms of daily water consumption or in terms of pollution flow, such as concentration of COD. In this particular site, the main consumption are cross-flow filtration due to an older equipment. The second main consumption is bottle rinsing. In conclusion, this data can be used to identify key points of water consumption and compare them with reference values. Next. Thank you. Let us now consider how to optimize the water. The first step, which is the simplest to implement, is to adopt the good practices. These good practices are frequently standard, common sense practices, principles. Sorry. We could list about 20 of these, and I will focus on a few of them. I will insist on the importance of having meters, especially connected meters, which allow for quick leak detection. It is important to note that all leaks are always visible. Other key practices include dry cleaning, the use of pressure for cleaning, energy recovery for hot water, the use of foam cannons, and so on. Next. Thank you. Once good practices have been put in place, the next step is to optimize the processes. An example would be equipment rinsing or water pushing. When pushing or rinse with the water, the first have a mixture of water and wine, then clear water. Monitoring water quality, for example, with a conductimeter or other sensor, can help define when rinsing is complete. EFA studies have shown that optimized processes can reduce water consumption by 20 or 30%. More generally, CIP system, cleaning in place, based on the same principle, can reduce water consumption by 20 to 60%. Compared with other sectors, CIP equipment are still underdeveloped in the wine sector. Next. Another example is process modification, which is often implemented when modernizing a workshop or designing a new winery. I would like to take an example of pigging system, which EFA tested about 10 years ago. The principle is to introduce a pig into the pipes and push it with compressed air or water. This system saves a large quantity of water and reduces the pollution load of effluent. However, it should be noted that this is a relatively complex process and requires specific design. It can also be costly. Next. Thank you. I would also insist on the cleanability of the equipment. To save water, the equipment must be too easy to clean. I will take the example of the surface finish of stainless steel, which can be either 2B or bright annealed 2R with a lower roughness. As shown in the data in the table on the slide, 2R comparatively save a large quantity of water and reduce effluent pollution. Next. Finally, I would like to conclude my presentation with the topic of water recycling and reuse. This is indeed a current topic. Europe is encouraging these initiatives. In France, regulation changed very recently in 2024 with the authorization of reuse within agri-food sector, including wineries. More precisely, a distinction made between processed water recycled and treated wastewater recycling. The potential water savings are significant, but precise technical data on health risk and contamination control are still lacking. Cost feasibility also remains to be studied depending on the volumes involved. Thank you for your attention. Thank you, Gracie.
Thank you very much, Jean-Michel. And just a quick note for the French participants, through the working groups that will be announced later on in the presentation, we can dive deeper into the subjects and the good practices, the audits that are proposed by the IFV and in the presentation of Jean-Michel. And it will also be the same for the other European producers that are with us today through your local clusters and technical centers. And that also reminds me, even if you are not a wine producer from France, Italy, or Spain, Portugal, Germany, you are of course welcome, and we are happy to also work with you through this project, and please get in touch on how that we can be of assistance. So thank you very much, Jean-Michel, for your presentation. So we are a bit ahead of schedule, and I will just check with one panelist, Dr. Nardi, and we will go ahead and have you present, if that's okay with you.
Yes, can you hear me?
We can
with
hear
a lot
you.
of noise,
Yes.
or a lot? Just 1 second. I'm trying to get it better. Thank you. waiting a minute. Is it a little bit better here?
It's a little bit better. We cannot see you, and the sound is
Just
better.
1 second. Well, just 1 second. I will turn on my camera and hello everybody.
Hi.
I'm really I'm sorry, but I am now in Italy, the biggest fair of wine in Italy. So the connection will be not the best. If you cannot hear me, please interrupt at any moment.
Okay, thank
Stay
you,
here.
Dr. Nardi. I will just explain to our visitors in the schedule. So we will have our first panelist, Dr. Nardi, speak right now for about 10 minutes, and then we will move on to the coffee break and then finish with the other panelists. So thank you very much, Dr. Nardi, for connecting even in the busyness of Italy. So the floor is yours.
So here I am. This is my, can you see my screen? Okay. Here is my presentation about some good practices that are now in place in some projects that we have in Italy, and those are serverless. And these are some important projects that we have about energy saving. So, energy saving in winemaking are related to consumption of um, uh, for cooling during fermentations. This is the focus of our projects that are all carried out in wineries, so at the industrial scale. What we have realized was that for winemakers, sometimes the lack of knowledge about how to improve their energy efficiency was a critical barrier. So we proposed a project to some wineries with the goal of changing their behavior, if possible, in white winemaking. So helping them to find the best strain and the best thermal protocol to secure alcoholic fermentation for white wines, avoiding excessive and unnecessary cooling. So this was the goal, to have the same wines as before, but avoiding to have cooling when this is not necessary. But the point is, what do we know about it? And all the information I'm giving you is now published in a document, a collective expertise document by OIV. So you can find it online among the collective expertise document of the International Organization of Wine and Wine, and is the current knowledge we have put together. This document shows all the experiments and surveys done to date about this topic, and I'm going to sorry, to talk to you about these ones that are the ones that my research group carried out. And you can see that we have tried to change the temperature thermal protocol in vinification to see if the winery can save some energy by changing this fermentation temperature. Trials, as you see, have been performed with different grape varieties, different yeasts, and different thermal protocols. What is important is the last two rows, and it's that the resulting wines have already been find by the consumers and by some panelists the same as before. So the winery could save some energy, or at least change their temperature without changing their wines. I will go a little bit fast on this and explain you our case studies in a few minutes. The first one was made in Franciacorta at the Muratori winery. We had 20 hectoliters, so real winemaking, but not very big. And we compared two temperatures with the same mask to see if the wine was fine and the winery could save some energy. We chose a strain that was able to complete the alcoholic fermentation with minimal changes in aroma. And the goal was to keep the same wine on the market. So no changes in the wine, but changes in energy used. This was the experiment. For sure, the fermentation at 19 degrees was faster than at 50, as expected. And you will see that a triangular test, there was no significant difference, and that aroma analysis also displayed small variation. So the goal was reached. But how much energy was saved? We measured this. My colleagues from University of Milan, the engineers, are doing this. And from the time of circulation of the refrigeration system, they can calculate exactly how much kilowatt hour are employed in fermentation, and the energy saving was 65%. So we had another trial, bigger scale, for 150 hectoliters, and different grape varieties. In this case, the Pinot Grigio was not a base wine, it was a still wine, and the Glera was again a base one for the Charmat method in this case. And we compared the winery protocol with the, let's say, new protocol. So the delta in temperature was 3 to 4 degrees. And again, this was the savings in the refrigeration system. And from the sensory and aroma analysis, again, the aromatic families did not change significantly, just a bit, that's true, but not that much. And sensory test was not significant again. So also in a bigger scale, we have a good energy saving. So going back to our general scheme, we had this energy savings that you can see at the very bottom. I also add a few words about a survey that we also did, much smaller than the one that Dr. Chiara Pezzi shared a few minutes ago. But it was about in the same regions, so Franciacorta and Prosecco DOC regions, sparkling wine regions in Italy. And we asked about the size of the tank, the temperatures, but I only show you this very significant answer, that is the willingness to increase fermentation temperature. We asked the winemakers if they would increase the fermentation temperature if research data supports an energy savings. We had 120 answers, and 80% of the winemakers said yes. And as you see from the graph, most of them did not put a limit, not no more than 1 Celsius degree or 2 Celsius degree. They said as suggested. So this is very interesting for us. And another few words about a new project. We are now going on and focusing on sparkling wines. So in the first part, we were speaking about the first fermentation. So good practices that now are in place in that wineries, Muratori and Santa Margherita was the second one, the biggest trial. But now we are focusing on the freeze de mousse, on the second fermentation. Here is a project that is now running till August, next August. And the very beautiful thing of this project that I'm glad to coordinate that is that it is cooperative. So we have two research institutes, but then we have an interprofession, and we have 7 wineries and a laboratory for analysis in enology. So we hope we will have more data from industrial sites again. And one of the goals of this project is to give guidelines to all the Prosecco producers about good practices that they can find we can find from changing temperature, avoiding again unnecessary coolings in second fermentation in this case. So we will quantify again the energy savings that the wineries can have in second fermentation. So here I have our team. This is the CREA team, the University of Milan team that is from 2 different departments, and I have already thanked the Consortio Prosecco that is already supporting this project. And thank you very much for your attention.
Thank you very much, Dr. Nardi, for this very clear and interesting presentation of what is going on in Italy. And I think maybe some of the other sparkling producers from other countries would be interested to follow the Prosecco project to learn about the optimized processes. So thank you very much and enjoy Vinitaly.
And sorry, I have to disconnect and I cannot follow the rest of the presentation. I'm really sorry for that.
Thank you.
Thank you. Enjoy your meeting.
So thank you to all. So now we will break until 11:30 before we continue with the rest of the panelists to listen to some more good practices and practical information of what wineries are currently putting into place in the wine industry. So have a nice coffee. Again, if you have a question, please write it in the chat or in the Q&R panel, and we will reconnect right at 11:30. Thank you to all of the participants. Hi, Domenico.
Ciao,
Buongiorno, ciao.
aspetta un attimo che verifico il video.
Sì.
Prendo un altro monitor.
Okay. Hi, Gracie.
Hi, Marco. Just the screen is blurred, so maybe take off. Ask Domenico to take off the blurred screen so that we can see both of you.
L'effetto. Infatti stavo cercando perché, come dicevo.
And Naria, if you can hear me, you will now be the first panelist. Naria, excuse me. And David. Hi, yes.
We are together, okay?
Okay, perfect. And your screen is also blurred.
Lo devo effetto.
Sì, adesso in sala.
Devo cercare dov'è l'effetto qua.
Es que no.
No. No, però mi devo cambiare il computatore.
If you click video and then unblur your background.
Hi, Gracie. I'm
Hello.
David.
Hi, David. Nice to meet you.
Can you hear me?
Yes, I can hear you perfectly.
So I will do the first part of our presentation, and my colleague Nuria will follow me with
Okay,
the second
perfect.
part of the presentation.
Perfect.
You
And
listen well?
well, it's blurred, so I'm not sure if you're going to move the camera, but behind you it's blurred. Okay, Marco, it's perfect. Domenico, perfecto. I can see both of you.
Good. Thanks.
And now let's try with the headphones. Is okay?
Yes, no, it's not the sound, it's the background. But as long as you change the camera, it's okay.
Questa no? Questa no?
Sí, ara he silenciat. I parla també de que tenim el fondo...
Ara ho tens per aquí.
És la presentació, condivido.
Hi, Arno.
Hi everyone. I'm Gracie.
Hello. So Arno, you will be the second presentation.
Okay.
Okay.
It's fine.
Better. Nuria and David, it's perfect. Thank you.
No, perquè igual no l'has aplicat encara, potser.
Sí, sí, m'està dient que ok.
Igual amb auriculars, sense auriculars.
Sí.
So we will start at 11:30. So a few more minutes for the participants to finish up their coffee and phone calls. Jean-Michel?
Yes.
Did you see the question in the chat? We will answer it at 12:40. But we will answer it during the Q&R session, but it's in the chat.
Yes. There is some questions.
Yes, it's in the host and panelist session. Y a-t-il des mesures de métaux dans les eaux de rinçage de bouteilles non réutilisées?
Okay.
Okay, so I translate it to English, but you can think while the panelist is happening. Okay.
Okay. Thank you.
Thank you. All right. Hello, everyone. So I hope you had a nice cup of coffee or a nice phone call. And we're back for the last hour and a half of our webinar. And this next session is dedicated to the panelists. So best practices in water and energy savings from a panel of EU wineries or consultants. And so we first heard from Dr. Nardi, a researcher at the CREA in Italy, talking about some best practices in Italy, specifically Prosecco, and also internationally. And we have three more panelists from Spain, Catalonia, from France, who will give some international and French examples, and then from an Italian group to give some more examples from a winery itself. So we will first get started with Mrs. Nuria Malin and Mr. David Carles from Torres in Catalonia in Spain. So Mr. Carles is head of the Department of Projects and Services, and Mrs. Malin is head of the environment. So two approaches for energy and water savings at Torres. Please, Mr. Carles, I think you'll be starting. Thank you very much.
Thanks, Gracie. Good morning, everybody. Can you hear me? Everything okay?
Perfect.
Yes. Let me introduce myself. I'm David. I'm the chief engineer at family-owned wineries, Miguel Torres. And jointly with my colleague Nuria, we will show you some actions that we are taking regarding sustainability and energy savings and water savings. The first part of the presentations, I will show you some key aspects regarding energy, and the second part will be devoted with water savings with my colleague Nuria. Let's share the screen. Now.
Tot el PowerPoint, ja compartim. Ahir em projectar.
Yes. Okay, can you see?
Yes, we just see it on with two screens. It's
okay.
configuration de visualisation at the top.
On the top.
The second, yeah, maybe click the triangle, the upside down triangle. Cambiar, sí.
Yeah, duplicar. Cambiar. Yeah.
Yes, perfect.
Yes. So let's start. First of all, I would like to tell you that the winery buildings represent maybe only a few or a small quantity energy demand compared with the other activities of our business. For example, emissions from packaging and transportation are many times higher than emissions related to the construction of the building operations. Also, the physical footprint of the winery buildings is usually small compared with the total sum of the winery's vineyards at land in terms of energy and electricity. But even though the construction of the buildings are an important and exciting area for us regarding energy and water savings, because the buildings are under our direct control. Direct emissions, direct responsibility, it's a direct opportunity for us. First part of the presentation, first slide, you can see one of our key wineries located in Pacs del Penedès. Pacs del Penedès is located in the middle center of Catalonia. And the design of our buildings, we apply criteria regarding sustainability in order to reduce the energy demand. First R is to reduce the energy demand. And then we are working also with savings. But regarding reduce, we are building our wineries partially underground. And also we use white sand to favor the albedo effect in order to reflect. during the construction phase, it's a good opportunity to install geothermal energy systems that allows us to take advantage of the constant temperature of the ground. Partially, the building is underneath of the soil, and then the consumption of the air conditioning, both in the winery and the tanks, is lower. If we are moving to the energy consumption or the energy chapter, now I'm showing you the total consumption of the total businesses of the company. These numbers are related to the whole wineries that we are running in Spain. No? So it's not only our headquarters located in Pacs del Penedès. And I can show you numbers from 2022 and 2023. The numbers related with 2024 are not still available, but I can assure you that are better. For example, you will see that we are in the path to reduce the total energy consumption, and the renewable energy use has been increased. In big numbers, we are running photovoltaic panels at the range of 7 megawatts, and we are producing yearly more than 8 megawatts of our energy. Also, we are selling our excedents, and we increased the self-consumption over the total energy consumption from 21 to 25%. You can see on the left part of the graph that the soft green is related to electricity. The hard green is related with another renewable source like biomass boilers that I will enter in detail later. We are doing energy efficient technology in our facilities. The first example, so we are running a lot of photovoltaic panels. We installed during the last 2 years, we doubled our surface installed in photovoltaic panels. And now we think that during this 2025 year, we will be able to become a 50% self-sufficient in terms of energy supply directly. Here we can see a nice picture of our winery in Pacs del Penedès, with that it's plenty of photovoltaic panels. And our goal, linked with our Torres and Earth program, is that we are achieving to become a carbon neutral winery before 2040. We are on the path, and we are always looking on that. And a good example of energy efficient technology that we are running is regarding the biomass boiler that we have in our wineries. We installed a big biomass boiler in 2012. It has been running during the last 13 years, and it allows us to reduce the natural gas consumption up to 90% and the electricity consumption up to 10%. I will notice you that this biomass boiler, it's linked to an absorption equipment on the bottom part, left bottom part of the slide, that use a bromure lithium solution that gives us chilled water. This chilled water is used for refrigeration of the buildings and the tanks. Now I will give the presentation to my colleague Nuria.
Thank you so much, David. I try to explain in a few minutes about our water management. And first of all, I want to show this picture. This is the map of our region. We stay in Catalonia. Sorry. We are here, more or less, not so far from Barcelona. And this is Catalonia. You will see two very different parts. The green part, it's influenced with the main river in our country, Ebra River, and the rest part it's Concas Internas. There are different short drivers, and this is all the capacity of reservation of all of this area, the color area. And it means this is a picture that I take it from the government of the webs of government on 21 of February. You will see in that date, it's only a month ago, we only have 31% of the total options of capacity of our reservation. It means that it was less than, they say more or less 20% less than the last 5 years. The government take these colors of traffic and will say, if you have blue ones, it's better than the red ones. It will see each one color, it's a village. We have in that moment of green one. It means that we can use water for all uses we need. I will show the same picture from today. You will see we have last year it rained a lot in our region. In February it was 31, and now we are in 64%. It means that we have more reservation. It means that maybe the next month, especially the summertime, it will be best for us. But also it means that it will change, and we depend a lot of the rainwater. This is the reason that in our cellar, we take care of water, and we are very, we have designed a plant, invest plan, just to take care that we need water for all the process. This is a picture, this is a real picture. This is our visitor center. It's in Pacs del Penedès, and we have the main prawn water. It more or less, it's 25,000 cubic meters, and we put all the water from own wells. It will be more or less 40% and rainwater. And this is the water that we use in the cellar. And also the bottom picture, it's another pond. It's an irrigation of the capacity is 12,000 cubic meters, and it's used only for irrigation. You know, the climate change, it's affect a lot. All the region, and especially the winery, it means that we need to irrigation our vineyards, not only for production, also in the last 2 years, it rained less than the average, and it means that our vineyards need for survival, not only for production. And about the users, we use sanitary water. We also have a reuse plan. All the water, all the wastewater, it goes to the treatment plant, and 45% reuse, and we can use in the cellar for cleaning and refrigeration, and one part from irrigation, private garden, and from the last year also vineyard irrigation. All the irrigation, it will be from regenerate water. I'll show you these optimal and very nice pictures, but this is really, these are pictures take last harvest time. It was in summer in 2024. And what happens last year, it's not rain. Obviously, we reduce the capacity of obtain water from the wells. More or less, you will see 50% less, and also the rainwater. And obviously, for this region, we have to take an action plan. The seller has a lot of invest just to obtain the necessary water that we need for production. And I will show you only four the main action that we do in the last years. We have a water treatment plan. All the well water goes through this infrastructure, and we prepare all the water for the quality when obviously we need in the cellar. And also we can rainwater collection. We from the roads, more or less 12 square meters, and also all the water go to the treatment plant, and we have another reuse plant that more or less 40% of the water that goes there go back to the cellar, and we use 70% for cleaning and refrigeration and 30% from private garden and also for irrigation. Masla Plana, this is the vineyards that go around the main cellar in Penedès. And also from the last year, we have the capacity to irrigation our vineyards in Masla Plana. I will show very few dates, and that I will show that last 7 years we can improve our efficiency, and we reduce 22% of the use of the almond quantity of water in the cellar. But I will show you for us, it's very, we are concentrated on this blue line. You will see the year after year, it's less. It means the wells we can obtain less water, and also we depend a lot of rain use. And obviously, when we have these years with a drought, especially in our region in Catalonia, we have to use water from the mains. That it means that in the future we do a lot of actions until now, but it means that we need water, not only for irrigation, also we need water for all the cellar, and we need to obtain more water and obviously be more efficiency in the cellar. And I think it's more or less what I try to explain with you. Thank you so much for your attentions.
Thank you very much, David and Nuria, for this presentation as one of, I think, the pioneers in sustainability and in energy and water management. So thank you very much, and I hope that you'll be able to stay to listen to your peers from other countries about their practices as well. And thank you very much for this intervention, this presentation.
Thank you.
So, our next panelist is Arnaud Hillen from Overdrive Engineering, so an engineering firm based in Bordeaux who works on some winery projects. And Arnaud will speak on behalf of some wineries to give examples of other practices in energy and water savings. Thank you, Arnaud.
Thank you, Gracie. So I will share the presentation. Okay. Is it okay?
It's perfect.
Okay. I'm Arnaud Hillen. I'm partner at Overdrive. We are a multidisciplinary engineering firm, and we provide consulting, global engineering, and project management services in the field of industry, especially wine and spirits, infrastructure, and real estate. And we are focused in sustainable development with a strong taste for technique innovation and challenges. And today, I will present 4 use cases project we designed. The first one is a very famous winery in Medoc. The second one is in Mexico, in Baja California, a new cellar in œnotourism resort. In the use case 3, we'll travel to Cognac in the industry of spirits. And for the use case 4, it's a smaller project and a low-tech approach. So save energy and water by renovating existing buildings. The best saving is always the energy and the water we don't use. So first, in the project, we try to reuse and reform buildings that are existing. In this example, we had a very large building, and we have the choice. The owner didn't know if he wanted to reform or to create a new winery in other part of the vineyard. So we asked for a very detailed laser captation of the existing building, so we could try different design and know if we can reuse the buildings as they were, or little, or with some little difference. In this example, we saw a former stainless tank area, and it's transformed in the new reception area. So we used the basement for the press. The levels were okay to make the reception, the cold room, and the sorting line, and it all well fit with the new process and the modern process. So we could keep the shape of the building and the traditional shape of the building and improve the process. And with this approach, we could make a very modern architecture and a very modern technique, but with saving a lot of energy with the reforming. A new building is about 40 or 80 times more energy and CO2 consumption than renovating. So we did the math in this project and we presented, and it was very important for us to keep the patrimonial aspects and to save energy by renovating. In the second one, it's a little different. We are in Baja California. It's an ambitious and luxury project. We have a Michelin star restaurant in the cellar beneath the tanks. So we know that we will create a lot of needs of energy and water with this new project. It's really related to the tourism. We have villas and hotel in the project, but it's no reason to try to make the better thing with the energy and the water. So we design a project that share energy and product the energy locally. First, we product electricity by solar panel in an architectural way. So you can see in the roof of the circle building special panel designed for the project to make a good point of view on the building and also product energy. And very interesting, we share the energy between the needs of the cellar and the wine process and the restaurant and the hotel. So with the thermodynamic process, we share the cold water and the hot water between the need of the tanks of the restaurant and the resort. So this allow free energy to be shared between different uses in the project. And because it's a little remote in the valley of Guadalupe, we need to treat and produce all the needs for the winery and the tourism. So we have a water treatment plant. We have a recovery of the water. We sanitize the water for the project and for the hotel. And we use the waste of winery to make CH4 production. In this third use case, we travel to Cognac in the spirit industry, and we will talk about land use and losses. The spirit industry use a lot of land. They need to store the barrel for 10, 15, 20 years. So it's a lot of space needed, and it's artificialization of the ground. So the water and bioenvironment is impacted by that, and we cannot make big buildings because we have to they have to be not so close to avoid fire transmission. So usually, traditionally, they store the barrel in a pyramid form. To increase the storage, we design a nine level storage barrel that reduce the need of space, the need of energy to create and to construct the buildings. And also, they had a lot of losses. Alcohol production is a lot of energy, so it's better to sell it and use it and drink it than to make it to the ground. So we design an automated filling barrel line. So the barrel are filled with a robot arm and fill automatically. That reduce the losses and allow a barrel wash with less water. So with that, they can move the barrel full and not use difficult filling into the pyramid storage. We also design a two-level wooden cask tank, and it was the first one, and it's good to reduce by two the artificial grounding. In the last project I will present, it's another approach with the big money needed in the 300 project. We also provide engineering for smaller projects. It was a farm transformed in a wine cellar, and we use the north room to make the cellar, and we took advantage of the stone wall existing and apply a plant fiber insulation. So we tried cork, hemp, and straw, and we did a thermal simulation with the winemaker. He didn't want to keep the temperature as low as the big winery that's require sometimes 14 or maybe 12 degrees. So with the stone wall, the orientation, and the fiber plant insulation, we could maintain the temperature between 18 and 13 degrees. It's now 5 years the cellar is working. So we have the 3 examples. This one was with hemp, but we also construct project with straw and other with the cork and dirt. To help this decision making, we also provide virtual reality visit, because all of those engineering is our concept before they are built. So with this with tool, we can help the decision of the owner. It's a small example. Thank you very much for your attention, and I will be ready for question later. Thank you.
Thank you very much, Arnaud. It was very interesting to see the four different approaches and also the different sizes according to the needs of the winery or spirits producers. So thank you very much. And our final panelist will be Mr. Domenico Dossio and Mr. Marco Fuscini from Italy. So Mr. Dossio is the investment manager of the Gruppo Caviro, and I will let him introduce himself. And Mr. Fuscini is the manager of the agri-cluster in Emilia-Romagna. So for our final panel, we will have some best practices from Italy. Thank you very much.
So good morning, everyone. Thanks for the attention. So Caviro is our key player in the wine sector located in Emilia-Romagna. And now I give the floor to Engineer Dosio explaining some best practices for what concerns water management, optimization of water use, and also some information about energy good practices.
Ok, io partirò con l'italiano.
Sì, sì.
Ok. Ok. Caviro è composti 14.000 coltivatori nel territorio nazionale Italia, con 385 milioni di fatturato, 560 dipendenti, 7 siti produttivi.
So Caviro is a big cooperative in Italy with 14,000 members and winemakers, 385 million euros of turnover, and 561 employees.
Il fatturato è diviso 64% vino e la parte materie prime e biomasse.
64% of the turnover is related to wine and 36% of circular economy and byproducts best use.
Ok, questi sono un po' nel nostro territorio tutti, diciamo, i soci distribuiti sul territorio su 8 regioni.
So 8 regions in Italy are interested in the implementation of the activities.
Qui cerchiamo l'economia circolare, il vantaggio della materia prima dalla vigna alla vigna.
So you can see the circular economy good practices from vineyard coming back to vineyard with very, very important recuperation.
Esatto, qui l'obiettivo ONU 2030.
So 10 sustainable development goals are affected, of course, including clean water management and clean energy.
Ora entriamo nello stabilimento di Forlì.
The Forlì wine plant. Forlì is a city between Bologna and Rimini in Romagna.
Una superficie di 150.000 metri quadrati con 1 milione di pezzi prodotti al giorno.
You can see the surface of area and 1 million of units processed per day and 223 million units per year.
Yeah. Certificazioni volontarie.
Several certifications of quality standards.
Ora entriamo nel cuore dell'acqua.
So, about water management.
Ok. Da qualche anno monitoriamo in modo continuo, settimanale e mensile i consumi idrici dei vari reparti di stabilimento, dalla produzione alla cantina. Questo perché ci aiuta poi a capire dove andare a intervenire per ulteriori investimenti e riduzione dei consumi idrici.
Very important, the weekly monitoring of the consumption of water divided by internal department. This is, of course, very important in order to organize appropriate actions of improvement of the implementation.
Ok, il nostro processo di potabilizzazione delle acque, abbiamo 2 pozzi dove preleviamo l'acqua.
2 artesian wells.
Esatto. Facciamo uno stoccaggio con una colorazione circa 2 mg litro di...
Yes, use of chlorination around 2 milligrams per liter.
Esatto. Poi facciamo un trattamento con filtro, mediante filtro deferrizzante.
Then de-ironing filter, treatment with the de-ironing filter.
Esatto. Poi facciamo trattamento mediante filtro a carbone.
Following water treatment using carbon filters.
Poi facciamo un trattamento ad osmosi inversa.
And then reverse osmosis treatment.
Ok. Infine, al fine di mantenere invariate le caratteristiche microbiologiche dell'acqua, facciamo un dosaggio di biossido di cloro a 0,6 mg litro.
At the end, chlorine dioxide intervention with 0.6 milligrams per liter.
Okay. Nello stabilimento è presente un impianto di depurazione.
In Forlì plant, they have a depuration plant.
Equivalente per circa 10.000 abitanti come reflow che può gestire.
Equivalent for capacity, overall capacities for 10,000 inhabitants.
Esatto. L'impianto è composto da serbatoi di accumulo.
With a wastewater accumulation tank.
2 vasche di ossidazione.
2 activated sludge oxidation tanks.
Per rimuovere i principali inquinanti dell'acqua.
To remove the main pollutants.
Poi nel 2020 l'azienda ha investito per mettere giù un impianto MBR.
Starting from 2020, Caviro has invested on MBR technology, membrane bioreactor.
Ha lo scopo di ultrafiltrare il fango.
With the aim to ultrafiltration of the sludge.
E depurare e fornire acqua depurata per il recupero.
And provide purified water to be recovered for the system.
Impianto, una volta che abbiamo fatto il trattamento di ultrafiltrazione, andiamo sull'osmosi inversa.
Then we go to the reverse osmosis technology.
Esatto. L'acqua passa attraverso l'impianto, rispetta tutte le norme di riferimento per le acque potabili.
Okay, the water comes.
Legislazione e decreto.
Comes to the reverse osmosis plant with the compliance of the national decree related to quality standards.
Al fine di mantenere invariate tutte le caratteristiche microbiologiche dell'acqua.
In order to maintain all the biological characteristics of the water.
All'uscita di questo impianto osmosi abbiamo un dosaggio del biossido di cloro, che è quello che ho anticipato prima.
At the end of this reverse osmosis plant, we have a dosing of 0.6 milligram per liter of chlorine dioxide.
Okay. L'impiego di tecnologie avanzate ha permesso di soddisfare il 40% del fabbisogno dello stabilimento.
All these technologies utilized allow to reach the 40% of water requirement of Caviro.
Ok, per un totale di circa 57 milioni di litri di acqua.
with a total of 57 million liters of water recovered.
Da oltre 15 anni monitoriamo il consumo, che questa è una parte importante, del consumo idrico di questo stabilimento. Negli anni abbiamo fatto gli investimenti, come vedete, dal 2020 in poi, si vede una riduzione drastica dei consumi idrici prelevati dal sottosuolo. Come vedete, la linea blu è l'acqua prelevata dal pozzo.
Okay, this is a very important slide showing the output and the important results in terms of water recovery. And starting from 2020, some good results have been reached in terms of osmotic recovery water in the yellow line.
Esatto. Si vede qui l'incremento da 2010 che eravamo a 0 di acqua osmotizzata, piano piano con piccoli investimenti. Nel 2020 è stato fatto l'importante investimento, abbiamo potuto recuperare e raggiungere il 40% già del 2021, 57, qui siamo in metri cubi.
Okay, so you can see in 2010 until 2014, 0 cubic meters recovered. Starting from 2020, around 40% of the water recovered, and with good results also until now.
Ok, e qui si vede di conseguenza anche il prelievo dal pozzo, che ha una riduzione importante da 144.000 metri cubi, arriviamo a 101, 85, 85 e 90 lo scorso anno.
You can see a good result in the blue line on the top, Pozzi means wells. So 2020, 144,000 cubic meters taken and reduced to 90,000 cubic meters in 2024 with a good performance.
Grazie per l'attenzione. Vorrei far vedere una breve slide, un video, perché oltre a questo recupero l'azienda ha investito tanto anche sulla parte energia.
Thanks for the attention. If you agree, we have a very brief video showing the energy results obtained thanks to some investments.
Yes, we have time. Thank you.
Is it possible, this?
Yes, there's time. Please go ahead.
Okay, thank you. So it is a very brief video of around 1 minute.
Lo vedono?
Can you see it?
Yes, we can.
Okay. So, of course, this is not related to wine cellars, but it is also very important for Caviro Group in order to optimize the use of renewable energy.
Ok? Con questo impianto è stato inaugurato lo scorso anno, nel 2024. Lo stabilimento di Forlì è autosufficiente al 100%, in quanto una parte di energia, come avete visto prima, l'88% di energia viene prodotta con un impianto di cogenerazione.
Okay, set up last year this investment, so the Forlì plant is 100% self-sustained by this renewable energy.
Ok? E il 12% con il fotovoltaico sopra il vigneto.
Okay.
Per arrivare a coprire il 100% del fabbisogno di questo stabilimento, che è 10 milioni di kilowatt anno.
Okay, thanks to the agrivoltaic plant with a 12% of contribution, and also the remaining part thanks to a cogeneration plant, it is possible to cover the 100% of energy demand for the overall processing.
Ok, l'impianto aiuta anche a ridurre il quantitativo di acqua necessario all'irrigazione del vigneto di circa il 25%.
This plant helps also to reduce the water demand by 25% overall.
Ok, io avrei terminato.
So thanks for your attention. We are available for further questions.
Thank you very much, Domenico and Marco, for this presentation and to learn more about the Caviro Group. So that concludes the panel from the different European countries and some actions that have been put into place. Before we go forward with questions, some other projects will have the floor to share the opportunities and how to go forward through these actions. So now Alba Valles, the project manager of WatEnerWine, who you heard from at the beginning of this webinar, will speak about more on how to get involved in the project. Please, Alba.
Thank you very much, Gracie. Can you all see my screen?
Yes.
Perfect. And thank you everyone who's listening. Hello again. It's good to be back. For those who have joined us after I presented earlier, I'm Alba Valles. I'm project manager at Innovi, the wine and grape cluster of Catalonia. We're nearly at the end of the sections of this webinar, and we have a space for questions and answers after we speak. Okay, so for this last part, we wanted to have a brief look at opportunities for collaboration with stakeholders through the project, and we're hoping to inspire you to participate and take advantage of what the project may offer. So let's dive in. How can stakeholders get involved? Question? Okay. So starting this year, we have 3 upcoming collaboration actions to support SMEs, wineries to uptake resource efficiency technologies in the field of energy and water, and specifically in energy efficiency, renewable energy, and water management and efficiency. So 2 for producers. On the one hand, we have thematic working groups to share needs, common challenges, and knowledge. So what we have. So we have created regional working groups to tackle the 3 project topics, followed by a final working group at a European level, which will encompass the 3 topics altogether. So the first batch of these regional working groups will take off next June, so this year in 2 months, and the other 2 batches will be spread out in 2026. And I say batches because there will be regional working groups, so 1 in France, 1 in Italy, and 1 in Spain. These working groups will serve as platforms to foster collaboration among wineries, their challenges and their needs, and energy and water technology providers, as well as support sustainability improvements by defining objectives, identifying technologies, and providing actionable solutions. On the other hand, we have missions for wineries, so support to SMEs to implement best practices. Following a financial support to third parties plan, one second. Okay. Thank you. So following a financial support to third parties plan, 3 missions will include visits to wineries that successfully implement water efficiency and sustainable energy measures, as well as visits to agri-food technological centers for capacity building activities. So participants will be selected according to criteria that we have developed and will be published, and will get to be funded the travel costs of these visits. Moving on to actions specifically for providers. So once a compiled list of common needs from producers is ready, the agri-food technological centers and BSOs will define technical specifications of the sustainability improvements objectives for each group and region. So based on these results from the working groups, a call for technology providers will be launched through the ACCP platform to provide a compilation of solutions. So this call will result in an innovation catalog with the compilation of the chosen technologies fit for the set challenges, as well as the inclusion of providers in the sustainability partnership. This is a brief and quick look at the actions that we have prepared. This is all for today's explanation. And with this, we hope these activities resonate with your companies, and in the future, you want to join us and collaborate to keep pursuing the sustainability transition and align with the cooperation and collaboration, and to strengthen sustainability partnership in the agri-food ecosystem. I leave the floor to Ibrahim Serdar, who is the coordinator of the project Oasis, to explain a little bit about what you're doing in sustainability as well. Thank you very much.
All right, thank you so much, Alba. You can all hear me?
Yes, perfect.
Okay, perfect. So thank you so much for this opportunity on behalf of my organization and also the Oasis partnership. So can you see my screen now?
It's loading. Yeah.
Right now it's okay?
Perfect, yes.
All right, perfect. So hello everyone, this is Ibrahim Serdar Koçar. I'm representing İzmir Commodity Exchange as the coordinator of the organization of the Oasis project, but also at the same time I'm representing the partnership of the Oasis project. So as one of our partners are already in the participant list, so I'm also like on behalf of them, I'm also representing the project as well. So our consortium is like quite similar to the consortium of Innovi project, but WatEnerWine project, by the way, because since we are dividing two main products of like the Mediterranean region, is like one of them is like grape and wine that you are sharing, and on the other side we are having the olive and olive oil on that side. So that's why our consortium is like pretty much the same regarding the countries. We have like 6 partners from 3 clusters and 3 technology centers from Italy, Turkey, and Spain. Basically, like we have 2 teams. We are also funded under the same program, single market program, and we will be working for 3 years again. And we have 2 main themes, which one of them is the material efficiency, and the other one is also the reducing the food loss and food waste during the process of the table and olive oil production. So the sector mainly is table and olive oil production. Our target groups are the SMEs mainly, who are actually producing the olive and olive oil within their organization, within their production chain. And our aim is to creating a cluster, increasing the competitiveness of the SMEs throughout tackling mainly the material efficiency in the process and the reducing the food waste problems for the SMEs that work in that sector actually. So mainly we are trying to reach like 150 SMEs, like 50 SMEs from each country to develop the sustainability of the SMEs, and we are trying to get them more acquainted and more familiar with the EU Code of Conduct and responsible food and marketing practices through the whole process. So we are trying to create their awareness about like sustainability, especially water efficiency and energy efficiency. So considering material efficiency, we're working on mostly about starting from the olive itself. So water efficiency and energy efficiency are like the main materials that we're using through the whole process. So that's why we're trying to increase the process on that side. We are trying to adopt the resource efficiency technologies, as we are going to be sharing the best practices from Italy and Spain mainly, to disseminate through our between our all SMEs in our all cluster, so that the SMEs will be able to benefit from their own practices, and through the cluster system that we would like to create even more best practices throughout the whole project actually. And also as the last objective, so while we are reducing the food waste and food losses, so we're also trying to develop we are trying to create a more a competitive environment for the whole SMEs during the whole supply chain. So basically, we have like the SME assessment. First, we will try to understand what's going on with the SMEs at the moment, and then we will create their like capacity. We will try to increase their capacity with capacity building, with best practice sharing, and also throughout the process, we will have green transition advisors, and we will try to explain them and create their capacity about one-on-one and with collective support. They will be supported during the whole process, and then we will try to understand their possible we will try to increase their possible sustainability even after the project with a 10-year projection of the whole process actually. So why Oasis for the SMEs? That we are trying to tackling negative effects of the climate change in olive oil sector. So we will provide like free trainings and mentoring support for the whole SMEs, cooperation between the SMEs and the institutions, which is like the biggest benefit of having a cluster over here, and then increase the awareness on green transition, material efficiency, and food loss themes. Networking through the events and clustering, and also the EU level of recognition by the SMEs through the whole using the European cluster collaboration platform and like different possibilities, so that the SMEs will have more availability to show up and to increase their recognition by on EU level as well. So this is all from the whole project. So just to give a general aspect from the project side. So if you would like to contact us, so this is our information. You can also follow our social media accounts. So thanks again for the whole opportunity for having us here. So thank you on behalf of the Oasis Consortium. Thank you.
Thank you very much, Ibrahim. It's interesting to see some other industries and the sustainable transition. And I would, of course, invite any participants who are also working in olive oils to contact the Oasis project and also benefit from their support to SMEs or companies who are interested in a market, in diversifying their market towards olive oil. I think that Ibrahim would be happy to be in touch. So thank you very much for the occasion to learn about this other project towards sustainable transition. Thank you. And as the last presentation, I will share a bit about the Wine Innovation Collaboration Alliance, which is an association that is currently being established thanks to a previous single market project, European project from the European Commission, EPAWI, which some of you may have already know about, and with whom we have very similar partners for the current WatEnerWine project, as you can see with the logos below. So I won't take up too much time because I know we want to get to the questions and ask the panelists and the experts a few more questions. I just wanted to share a few tools that we have thanks to WICA, the Wine Innovation Collaboration Alliance. So the goal of EPAWI was also to support SMEs, suppliers in their international development. So through international missions and webinars, we were able to support SMEs and organize mini events trying to promote innovations and technologies of the supplier companies, which of course answer the needs of the wine producers, from climate change to cost, cellar, and vineyard. So throughout the whole value chain. And through this, we were able to create the innovation catalog, which is kind of the base of the innovation catalog for WatEnerWine that will be launched later this summer. So here you can see a screenshot of some of the wineries that have answered their solutions in the chapter of decreasing energy and water consumption in the winery. And the goal through the innovation catalog of EPAWI is to have 9 themes from the vineyard to cellar and to the sales, and to have a list of companies providing innovations which can help wine producers through their challenges. So this is one of the main results of the EPAWI project, which with, of course, many more than 45 solutions, the stakeholders who have accessed this innovation catalog. One of the other results of our project has been a survey with over 700 answers with the main challenges of the wine industry. And one of the final actions of our project was to highlight 12 of these questions and to put them on our website. So you see the link here, and I will add it in the chat afterwards. But from, as I said, the planting of new vineyards to winemaking in general, to the bottling, labeling, and shipping, we have selected 12 main questions that can be looked at by region. So global region, meaning Europe, North and South America, and also the target EPAWI countries, which were the United States, Chile, Argentina, and South Africa. And you can also organize the graphs by role, whether that be the grape grower or the winemaker, a supplier, a researcher, or a consultant, and also by size. So there will be 3 ranges of size to look at. So if you would like to look further into some of these challenges, we have over 40 questions, so 12 which are highlighted on the website, but the data for more. So if you're interested to know more and to go further, we're happy to be in touch. So as a conclusion, WICA, the Wine Innovation Collaboration Alliance, aims to assist and accompany the producers in their challenges through the supplier solutions, but also cross-sectoral solutions. As we learned earlier, we can learn from other sectors, from other industries, of course, through the research knowledge, and then the business support organizations and the technology centers to facilitate these exchanges and bring knowledge to each of the stakeholders. And thank you for your attention. Our next event, well, you can meet some of the partners of WICA at a future event, InnoForum, in Verona, Italy, from the 21st to the 23rd of May, where some of the suppliers that have been highlighted in the innovation catalog will also be presenting and have booths, as well as, of course, a very strong research panel sharing the latest knowledge in the wine and wine sector. So please get in touch. We hope to see you either online or in Italy to know more. And also representatives from WatEnerWine project will also be present at InnoForum to speak with you and answer any questions related to more of the subjects, of course, in water and energy savings. So thank you very much. It is time for questions. I will stop sharing my screen. So I think we had a first question for Jean-Michel concerning metals in the rinsed water. Jean-Michel, do you have an answer?
Yes, thank you, Yossi. But at the moment, we don't have the response of this question, but more generally, I will insist of reuse of water. We can have two objectives. The first objective is to obtain drinking water quality. but it could be very expensive if the volumes are few. And the other objective is not drinking water quality, and we have to define a fit for purpose quality. It is very difficult, and we have to make a health control plan and to update what we say a guide of good hygienic practices in the winery. It's okay.
Thank you, Jean-Michel. Pauline, I'm not sure if the person who answered the question is still here, but I think if she has further questions on metals in the water, she can be in touch. And thank you for the reminder on the difference between drinkable water and then the non-drinkable water, which is, of course, an important difference to make with water reuse. I see someone has their hand raised, Mr. Bruno Esteves. I can try to, oh, hand is gone. So maybe it was a mistake. If you have a question, if you want to raise your hand, we have a few more minutes so I can let you speak, or of course you can write it in the chat. So I have a question for the panelists and the experts. I'll let whoever wants to answer about the management between a smaller structure and a larger structure. So some of the examples that we saw today were for some large wineries and large structures, but some of the good practices mentioned by the experts, they seem also to be able to be put into place in smaller structures. So I'm not sure if Aina, Jean-Michel, Arnaud, if one or a few of you would like to, talk about this difference between bigger and smaller properties.
Yes, yeah, sure. There are differences of course, I think of capacity of investment, of course, regarding large or smaller um, sellers, let's say. So you have to, of course, focus first of all on the diagnostic of the water cycle. I will speak on it regarding water, of course. But yeah, of course, you have to first of all have a good diagnostic of where we can reuse water, when we can optimize the consume of water in this industry production. So after that, when we know where are the most consumption places or processes in the winery, of course, we can detect it first of all. Then we have to choose which practices are more perfectly fixed in our company. So of course, all the best practices that we have shared with you can be applied in a small industry. Some of them are not very cheaper, so are not very expensive. The site. So first of all, but we have to analyze the water cycle. So only to have the chance to do it and the necessary focus on the sustainability.
Thank you very much, Aina.
Yes, I think it's really important to select the objective. In smaller projects, we cannot use the whole panel of solution we have. Maybe it's better, most of the time it's better to focus on one solution, sharing with the owner, and to work on it in this special area, energy or water, or one solution in energy, one solution in water, and not to try to reach all the solution, because yes, investments make you focus on low tech and reaching solution. It's very important to communicate on it.
Thank you, Arno. David or
Yes.
Nerea? Yes.
Yes, David, just to add, I totally agree with my colleagues. So you can work at a different scale in between small and bigger wineries, but also we are working. The small wineries are giving you the opportunity to work in small test or in pilots. So and then try to scale at a bigger wineries. Sometimes, for example, photovoltaic panels, obviously you can achieve a lot of energy with bigger roofs and then work at a minor scale in the small wineries. But these small wineries that are still useful to run small pilots or a small test in order to check this kind of solution could apply or not. So it's easy and faster and quick.
Thank you, David. Yes, that's a good practice to use these small wineries, and it also makes me think of the collectivity and through appellations or through groups of wineries to share these best practices and have tests in smaller ones and then bigger ones with maybe more economic investment power to be the pioneers. Thank you. Let me check if we have other questions. Mr. Gianni Ciorioli, I think there was a question.
Yes, Gracie, thank you. Again, into this issue of small wineries, and Arnaud was among so many good tips from all the speakers, all the panelists, but Arnaud was mentioning the use of straw to, if I well understood, insulate the buildings. And the straw is a raw material which is very much abundant in many farms, also producing wine. So can you tell us something more about how is this technology? Can you actually use something a kind of waste material in-house produced, or do you need something very expensive coming from outside?
Yes, the using of straw in insulation, it's now better and better known. We built schools, high schools, wineries. The raw material can be used in insufflated straw between wooden structure. But the better is to use the straw compacted with a special weight and compact. We have to check the amount of water in the straw, and but all the data is now available to use it in different thickness. Most of the time it's 36 centimeter, but now we have a smaller thickness that can be used also. It's also good to apply it with the surfacing with the local grounding, or if you have the good quality of dirt, it's good mixing with the straw and the dirt facing in the insulation. So yes, in France we have good practices of straw in construction. It's now accepted by the regulation and the security check in France. So now it's possible to make it in a large scale for public building or private building. And if you want, you just contact me. I will send you the French regulation for straw construction.
Thank you, Arnaud. So a question for all three of our panelists. So you presented very interesting water and energy savings expressed in meters cube and kilowatts. Do you think that these savings are also reached in economic terms, considering the initial investments to either rebuild or to completely create a new structure? So I think we would be interested to hear if you have some results, economic results of these changes.
May I add that at Familia Torres wineries, we are checking regularly with the price of the power supply, with the price of the electricity. We are checking the return over the investment regarding photovoltaic panels. So since the last 3 years, it has been a big effort with this investment in photovoltaic panels, and our financial department is always checking and giving us feedback. And I can share with you that it's okay. So we are checking the total energy production and self-consumed per month with the price of the free market price electricity, and it gives us positive results. So the photovoltaic panels here in Catalonia are how we can say
sustainable.
Yes.
Yeah.
So financially sustainable. So it gives.
Thank you, David. And I think Marco, it was the same for Caviro. That I think he mentioned that 100% of the electricity needs are covered by the panels. And is that the same as well for the economic benefits?
Yes, we can confirm that the economic return for what concerns the energy agrivoltaic plants is very interesting, of course, in terms of self-sustainability. On the contrary, and Domenico can confirm about the water recovery is more an aspect of environmental sustainability rather than economic sustainability.
Confermo, la differenza è che noi l'acqua la preleviamo dal pozzo.
We take water from the wells.
Da sottosuolo.
Under ground.
Chiaro che se fosse una cantina che dovesse acquistare completamente l'acqua dall'esterno, potabile, allora il ritorno diventa veloce.
If a seller takes water completely from the aqueduct, for example, this is the case of an important economic return. In their case, it is more an aspect of environmental impact.
Esatto.
Thank you very much.
I would like to ask to say also that sometimes some investment can be difficult to measure. For example, in the case of water, because the water is very cheap, let's say. But I wanted to point out that if, for example, in the case in Catalonia, we have a very, very high and stressed out there. So the case is that if you don't have water, we can produce wine. So I want to point out this because sometimes it's difficult to measure some investments, but let's think about when we don't have when we don't have water. That's the point to have into account in the future.
Of course. Thank you. So maybe I have a final question, and of course, the participants, there's still a few more minutes if you would like to write a question. So for our panelists, how do you communicate on your energy and sustainability efforts? And also, are the suppliers that you choose, are their sustainability efforts important in your choice? So it's kind of a question about consumers, so your clients, and then also about your suppliers, and the communication about the sustainability efforts in water and energy. And Arno, maybe your feedback on your relationships with the wineries that you work with, and in relation also to the equipment that they might choose when working with you. I see Mark.
Yes.
Oh, sorry. Go ahead.
Yes. Thank you. It depends of our clients, but some of them are very strict on the suppliers, that they have to reach the RSE or the taxonomy needs that for the product we choose have to reach the global cycle of life to choose it in the project. In smaller project is different. It's more kind of a local and small circle providers, and it's important for them to know that the after services is good, so they want to know who is the provider of the machine, or it's like that.
Thank you, Arno. Marco and Domenico?
Noi abbiamo comunicato ai nostri clienti che la grossa distribuzione.
Caviro has communicated several times with the information campaign, particularly to the big retailers, which are the main partners along the value chain.
Esatto, e soprattutto anche gli organi competenti, perché hanno rilasciato l'autorizzazione affinché l'acqua possa essere rimessa in circolo sul processo.
And also informing the governmental institutions in order to inform them about the process and the benefits and bottlenecks, etc.
Esatto.
Thank you. David, would you like to share?
Yeah, regarding communications and outreach, we have our program called Torres and Earth program, and is the program that fits with the budgets regarding investments with energy saving, sustainability, and everything. Also, we are one of the founders of the International Wineries for Climate Action, that is trying to share all this knowledge regarding best practice and everything related with energy and sustainability.
Thank you. Thank you, David. So I do not see any more questions. And of course, if the panelists, if you have questions for some of the experts or the other speakers, please go ahead. And if not, just a quick reminder that we will send the presentations and the recording so to the participants and the registered participants so that you can have access to the information and the contacts if you would like to go further. For the wineries that are present here today as panelists and as participants, you are of course invited to participate in the working groups that will start in June, as mentioned by Aina and Alba. So they will first be organized by country, and then as a conclusion on a European level, so in English. So they will be with groups in Spanish, in English, in French, and in Italian, and then concluding meetings in English, kind of a new get-together similar to today to share the results of the meetings. And for the suppliers that are present here today, so you'll have the chance and the opportunity to be included in a new innovation catalog so focused on water and energy. And this innovation catalog will, of course, be shared with the wineries that are involved in the working groups, and also on a much larger scale through the networks of the partners of the WatEnerWine project. And so I will now let Alba Valles, a project manager, conclude this webinar. Thank you very much. And thank you also for staying connected, because 3 hours is indeed quite a long webinar, but thank you for staying connected and for your participation. Alba.
Thank you, Gracie. Just as a closing section, thank you all for being part of today's webinar on energy and water savings in wineries with cross-sectoral learnings. And a special thanks to our panelists for their valuable insights and inspiring contributions. Your commitment to the sustainability transition is truly shaping the future of the wine sector. And to our audience, we appreciate your participation and enthusiasm. Stay tuned, as Gracie said, for upcoming news and details on the collaboration opportunities that we mentioned. And from the WatEnerWine team, we wish you all continued success on your sustainability journeys. Thank you all and see you soon.